So we're going to be talking about more deductive reasoning here. So what we're leading up to is doing proofs. So the first stuff that we're talking about here are properties, and the first four are kind of go together because they're all operations. When you see me write these, sometimes I'll write prop equality like that. Sometimes you might see property of equality. These are properties of equality because they're things you're doing to equations. Okay, so all of these need to say property, and then either the word equality, the equal sign stands for equality, or the EQ for equality. I will abbreviate addition as add. Subtraction, you need to have at least the T, if not an R, if not the whole word subtract. Okay, you're never going to use the abbreviation SUB. And that's because I won't know if that's subtraction or if that's substitution. So you have to have at least 4 letters. It's kind of better if you use more than 4, like even throwing an R in there would be a good idea, right? But just don't make it SUB because I will not give you credit for that. So you got to have at least the R and the T in there. The R would be good. Subtract, the whole thing is fine. Okay, multiplication, I'll abbreviate as mults. Division, I'll abbreviate as DIV. For the operation ones, it is, you identify those as being what operation is being done on both sides of the equation. Okay, so you're adding 5 on both sides, or you're subtracting 18 on both sides. You're multiplying both sides by 2x. You're dividing both sides by 27. Something that you're doing on both sides of the equation. Okay, so, and you'll see right here, see how it's adding C on both sides, or subtracting C on both sides, multiplying C on both sides, dividing C on both sides. Not equal to 0. Remember, you're not allowed to divide by 0. That's why it says not equal to 0. But all of those are operations. Okay, the next 3 kind of go together, and they are ones that you probably are not familiar with. So the first one is reflexive, and these are still properties of equality. Okay, reflexive property of equality. Again, that just means it's something you're doing on equations. Reflexive says that something is equal to itself. Okay, something is equal to itself. So not just that the 2 sides are equal, but that you literally wrote the same thing. It's not like 10 divided by 2 equals 5. Okay, it's not saying that the left and the right side are equal, because of course they're equal, it's an equation. But that literally you have written the same thing on both sides. So like 2x plus 5 equals 2x plus 5. Okay, or 3y equals 4x, sorry, 3y equals 3y. Okay, that's reflexive property of equality. Symmetric property of equality, which I'll abbreviate reflexive like reflex, and I'll abbreviate symmetric like SYMM. Symmetric says that you can switch the sides of an equation. Okay, symmetric says you can switch the sides of an equation. I'm trying to avoid my G there. So you'll see symmetric over here. If A equals B, then you can flip the 2 sides and get B equals A. Okay, or it could be, they could be expressions like 3 4a minus 2 equals 4a, then I'll change letters. 4b, how about 4c? Then 4c equals 3a minus 2. You can take the two sides of the equation and flip them around. Paul.
For reflective property, when I like to reflect the other side of the equation, I like to before I do that. Like
no. No, if it's reflexive, it has to be the same exact thing on both sides. Otherwise, it'll be a different property. Okay, transitive. Transitive has, is kind of like, if you remember, we compared this to law of syllogism. And it goes, if, so here it is with the notation. If A equals B and B equals C, then A equals C. So because a whole side of the equation here matches a whole side of the equation there, we can cancel those and relate the first and the third. Okay, that's kind of like how syllogism was. If P implies Q and Q implies R, then P implies R. It's kind of like that. Okay, so transitive is if thing 1 equals thing 2, and thing 2 equals thing 3, then thing 1 equals thing 3. So you have to have a whole entire side of the equation that matches so that you can remove that and connect the first and the third thing, okay? The whole entire side is getting wiped out. So for transitive, one whole side of each equation must match. Okay, and then substitution, just like I said before, how you cannot abbreviate using SUB, you have to have at least the S in there, if not also a T. Okay, substitution, property of equality, you recognize that as just being replacement, right? You can replace something with something that's equal to. And then distributive, even though it has its own little box there, I'm not really sure why it's separated out because I don't think it's any more important than anything else, but distributive property is actually not a property of equality. It doesn't, like, I don't really care if you put property of equality. I'm not gonna be too upset, but technically it's called like the distributive property of multiplication over addition. So you're multiplying across into parentheses with an addition, or distributive property of multiplication over subtraction. So it's technically not a property of equality. Is probably why it's separated out. But distributive is one that students usually are good with recognizing. A times the quantity B plus C equals AB plus AC. You just do it so much in Algebra 1 that I think it's easy to understand. Okay, and then just like we have reflexive, symmetric, and transitive for equality, we also have those for congruence. This is where it's going to be different. Those of you that have been in Algebra 2, you probably didn't talk about congruence properties. Okay, this is reflexive property of congruence. Symmetric property of congruence. And transitive property of congruence. Now, I'm going to be picky about you writing property of congruence and property of equality. Okay, so every time that you're doing something on an equation, it's going to be property of equality. Again, distributive is technically not a property of equality, but if you write equality, that's okay. And then anytime that you're doing it on congruence relationships rather than equations, then it cannot be a property of equality. So options might be reflexive, symmetric, and transitive. So remember, reflexive means the same exact thing on both sides. So this is an example of reflexive with segments, and then here's reflexive with angles. So reflexive is the same exact thing on both sides. And again, it's congruence because they're congruence relationships. Symmetric. Symmetric says you're allowed to flip the two sides. So I'm taking my if and I'm flipping the two sides to get my conclusion. Okay, so the first one's with segments, the second one's with angles. For symmetric, I didn't say this up here, but sometimes it's helpful to think about kind of like a line of symmetry. So, you know, when you make like a Valentine's card and you fold paper in half and then flip it over, that's a line of symmetry, and that's like how symmetric is flipping. It's line of symmetry. Okay, or you can think switch is symmetric. And then transitive will be, again, you're going to have the same exact thing on one side of the two congruence relationships so that you can remove them and connect the first one and the last one. Okay. If thing one is congruent to thing two is congruent to thing three, then thing one is congruent to thing three. And then you have the same thing with angles there. Okay, so again, for transitive, the whole entire side of each equation, there has to be a matching whole entire side. So the same thing as I set up here. All right, so examples of that, if angle P is congruent to angle R and angle R is congruent to angle A, then you could take out angle R and say that angle P is congruent to angle A. Okay, that would be, which property is that? It's transitive property of congruence. Okay, and this will also be transitive. What would go in the blank there? What goes in the blank? N. Okay, so we want these to match so that they will disappear and we can relate X and Y to each other. Okay, for these problems with the if-thens, you're always saying what you're doing to the if to turn it into the then. It's what did you do to the hypothesis to get the conclusion? You're always going from the left to the right. What did we do to the hypothesis to get the conclusion? And you have to read it forward. Okay, this is how you want to talk to yourself when you're doing these problems. You're asking yourself, what did you do to the if to get to the then? Got to make sure you're going forward. Okay, so here, if the measure of angle 1 equals measure of angle 2, then the measure of angle 2 equals measure of angle 1. Symmetric. So you're flipping the two sides to get the conclusion. Property of equality because they're equations. Okay, if the measure of angle 1 equals 90 and the measure of angle 2 equals measure of angle 1, then the measure of angle 2 equals 90. Aiden, what do you think? Transitive? What are you taking out? You're right. I just want to know why it's transitive. Julia. Yeah, so it does not matter that this is in a little bit different format than it was up above. Measure of angle 1 is a whole entire side of the equation that's matching, right? So the whole side is getting wiped out and we're making those equal to each other. So again, when you read these, you think if thing 1 equals thing 2, and this is thing 1 again, is equal to thing 3, then thing 2 and thing 3 are equal. Okay, so we're taking out a whole side of the equation, making those equal. Transitive property of equality. Okay, if AB equals RS and RS equals WY, then AB equals WY. Because what's that? That's also transitive. So we're taking out RS and relating the first thing to the third thing. Again, they're equations, so it's a property of equality. Okay, if AB equals CD, then 1/2 AB equals 1/2 CD. Paul, what do you think that is? Tell me why you think it's division.
I guess it's because, well, I think it's because, like, if you're dividing each one by 1/2.
Okay, so this is actually multiplication or division. If you considered it multiplication, what are you multiplying by? 1/2. I would kind of, like, to me, it makes better sense to call it multiplication just because of how it's written. So I'm going to look at this and say I'm going to multiply both sides. And then multiply looks good. Multiply by 1/2. Because I think if you were dividing by 2, I mean, I'm not going to count this wrong, but I would ask you to explain why it's division. If you say division, I think that you would have written it like this, right? I don't think you would have put a 1/2 in the front. I think you would have written it as divide both sides by 2. Okay, so I'm not going to count that wrong if you say division. I just think that the format of the answer, I think it's better to call it multiplication. But you have to make sure you're going forward. Okay, it's from the left to the right. Okay, if the measure of angle 1 plus measure of angle 2 is 110, and measure of angle 2 is measure of angle 3, then measure of angle 1 plus measure of angle 3 is 110. So, tell me why it's substitution. We are simply replacing angle 2 with angle 3. So notice how the if equation and the then equation look a lot alike. Also notice that this has an and in it. There's 2 givens, just like with the transitive. With substitution, you're typically going to have 2 givens that you're combining together. Okay, that one is substitution. Tell me why that's not transitive. Or is it? Could I call that transitive? Number 5. Is that transitive? Yes or no? And why or why not? Andrew? Because why? I'm sorry, I missed it. In the first equation, you're adding and. Uh-huh. Okay, so for transitive, you have to have an entire side that matches. And when we try to do that, here's thing 1, here's thing 2, here's thing 3, here's thing 4. We don't have one of those sides that's repeating, right? We don't have a side that matches. So that one cannot be considered transitive. RS equals RS. RS equals RS. Lucy? Basic what? Reflexive what? Okay, property of, is it equality or congruence? Equality. Okay, don't forget that part of it. Okay, if AB equals RS and TU equals WY, then AB plus TU equals RS plus WY. This one looks a little different. It's kind of weird at first, and students struggle with this one a little bit. Any ideas? Just guess. What do you think? And we'll talk about if it's right or not. Well, okay, so if it's symmetric, I would have said if AB equals RS, and I wouldn't have even given you this. All I would have done is say, then RS equals AW, or sorry, AB. Okay, symmetric is literally just switching the two sides of one equation. So it's not symmetric. Abe, what do you think? Tell me why you think addition. Okay, so if you kind of notice AB, AB, RS, RS, what changed? Well, we added on this TU and this WY. Why are you allowed to add TU and WY on both sides? Why does that not unbalance the equation? Paul? Because they're equal, right? It's just like if I said add 5 on both sides. So basically you have the AB equals RS and just think you're adding TU on the left, you're adding WY on the right, and that's okay because they're the same quantity. Okay, they don't have to actually physically look the same. You're adding the same amount on both sides. That one's a little tricky at first. But that one is addition. All right, how about number 8? Carson, can you tell me what you think number 8 is? Good. Symmetric property of congruence. So we took the two sides there and we just switched them around. Notice symmetric will only have one given also. Back here, the addition one, this had 2 parts given. Addition doesn't have to have 2 things given. Like if I had just said, if AB equals RS, then AB plus 5 equals RS plus 5, then I wouldn't have had to give you a second given. Okay, but it does look a little bit more confusing when you have the 2 givens. Okay, now I also said here, state a property postulate definition. So there's actually some things that are not properties. What is number 9? If an angle's measures between 90 and 180, then the angle is obtuse. What is that? This one? It is a conditional statement, but it's either a definition, property, or postulate. Julia? Good, that is the definition of an obtuse angle. Now, I told you that you can always write definitions in biconditional form. Usually on these problems, they won't be written in if and only if form. Usually they'll be written in if then form. Okay. How about number 10? If L is between R and S, if L is between R and S, then RL plus LS equals RS. RL plus LS equals RS. What is that? Maya? That is segment addition postulate. So there will be these things that are thrown in, mixed in with your properties. Sometimes students try to call that like regular addition or substitution or something else. Hopefully that is something you recognize as something from chapter 1. This is not a property, okay? The last one is also not a property. If ray PQ is an angle bisector of angle XPZ, so let's draw a picture here. XPZ. PQ is an angle bisector. then those two angles are congruent. Anna, what's that? Okay, angle addition would say that this plus that equals the whole thing. Okay, but that's not what this conclusion is. You have a second idea? Yes, that is just a definition of angle bisector. It's saying because it's a bisector, the two parts will be congruent. Okay, now I'm going to, as you see right there, sometimes postulates and definitions be mixed in with the properties. Down on the fourth page, I guess, I put a list of kind of tried to sort of summarize everything that you would be using on these. So the properties are listed there, which is from today. But then also I tried to grab the definitions from chapter 1 that you would be seeing as possibilities, and then the segment addition postulate, and then the properties of congruence down here. Okay. So when you're trying to do those problems, you're trying to come up with the different possibilities. Hopefully that will be helpful at first to kind of see all that in front of you. Okay, so a proof. When you're looking at proofs, you're going to have a given, you're going to have a proved statement, you're going to have a statements column and a reasons column, and then sometimes you'll have a diagram. When you read this, the given is your hypothesis. So this basically says if 5x plus 1 equals 21, the proof statement is your conclusion. Then prove that x equals 4. Okay, if 5x plus 1 equals 21, then x equals 4. So the first step is almost always going to be given. Okay, that was provided to you in the problem. It is given. So they said, here's the equation to solve, and undo it. Okay, going from step 1 to step 2 is what you write over here. What is the property from step 1 to step 2? On both sides of the equation, we're doing what? Subtraction. And remember, you do not want to write SUB because I won't know what that means. You can write subtraction like that. You can write subtraction like that. You can write subtraction like that. Okay, but no SUB. All right, and then from here to here, that's what we're writing as a reason for number 3. So, division. What are you dividing by? Could you have called that multiplication? So you could call it multiplication by what? 1/5. So most people probably look at that and say just divide both sides by 5. But if you say division, I probably would mark it wrong and then ask you, why'd you call it division? If you said, if you wrote multiplication, and if I said, why'd you call it multiplication? And you said, I multiplied both sides by 1/5, that would be okay. Okay, just make sure you're always going from the first thing to the second thing. You've got to be going forward, advancing the argument. Okay, so these are the different parts of a 2-column proof. You have a given, you have a proof statement. You will usually in geometry have a diagram. These are algebraic proofs, so there's no diagram. Typically, you will have a diagram. Okay, you'll have a statements column and you'll have a reasons column. Those are the things that you'll see in a 2-column proof. You will never, let me write this over here. You will never, ever, 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 never, ever, ever write prove as a reason. Prove in this situation is a verb. Okay, we write given because given means this is your provided information, this is your starting point. You will never write prove. So sometimes students get down to this last step and they're wanting to write prove there. Prove is a verb. Prove is like, now go show why this is true. Prove could not be a reason. Okay, prove is where you're ending up. You will know that you're finished with the proof when your prove statement matches, what your last statement is. That's how you know you're done. Okay, but you're never going to use prove as a reason. Given will always be used as a reason because there's given information that you can use. Okay, recognizing the definition of congruence. Whenever you go between two angles, two segments have the same length and two segments are congruent. The reason is definition of congruence. Whenever you go between the measures of two angles are the same and the angles are congruent, the reason is definition of congruent angles. Okay, so it almost looks the same. So the way you would see this in a proof is it might say like step one. Segment AB is congruent to segment XY. Maybe that's given. And then step two says AB equals XY. They look almost the same. The difference is the first one's talking about the segments, the second one's talking about how their lengths are the same. The reason you know their lengths are the same is because you know what congruent means. If you didn't know what this symbol meant, you'd be like, I don't even know what that thing is talking about, okay? That is definition of congruent. And you can either just say congruence or you can say congruent segments. It doesn't bother me if you just say definition of congruence. Or maybe you would see the measure of angle 1 is equal to the measure of angle 2 is given. And then step 2 says angle 1 is congruent to angle 2. That would be definition of congruence or congruent angles. Okay, and it doesn't matter if you're going from equality to congruence or from congruence to equality, because it's a definition. It goes both ways, right? It's a biconditional. So whenever you see you're going from equation to congruence or vice versa, that's definition of congruence. Okay, and again, we are doing deductive reasoning. All right, let's do this one. Okay, what's the value of x? Justify each step. Okay, you're given that ray AB bisects angle RAN. That's your given. Okay, our prove is basically what is the value of x. That's what we're trying to determine. And then here's our statements column. And here's our reasons column. Now, what else you were given is the stuff that's on the picture over here. Sometimes there will be information on a diagram. Oh, I kind of skipped over this. Here's the things that you're allowed to use when you're doing a proof. Okay, there will be information given, and then you can always grab properties, definitions, postulates that we've already discussed. There will be theorems as we go through the material. There's going to be theorems introduced that you can use. And then sometimes there are things that are on the diagram, like for example, if you look at the picture and you say that angle 1 and angle 2 are vertical, that's something that you know because you know what vertical angles are. Okay, that's sort of like coming from the diagram, even though it's not given. This is coming from the diagram, even though it's not specifically stated as given, it is given information. Okay. Ray AB bisects angle RAN. That's your given. Almost always the first step is given. And sometimes there's more than one given, that one of them is used at the beginning and then one might be used later on. Angle RAB is congruent to, what should that second thing say? Angle RAB is congruent to angle BAN. What is their reason for that? Lucy, go ahead. Okay, do I write because there's an angle bisector? What do I write? That's what it is, right? You know the meaning of the word angle bisector. So you're going to say that is the, what do you call the meaning of word? Definition. That is the definition of angle bisector. I know what an angle bisector is, and that's how I know that because it bisects, then it makes the two parts congruent. Okay, the measure of angle RAB is equal to the measure of angle BAN. What is that? That is the definition of congruence. Again, see how it looks really similar? It's really just kind of a notational change. That's because congruent means the measures are equal. That is definition of congruence. You can say congruent angles, you can just say congruence. I probably usually just write definition of congruence. Okay, x equals, what goes on the other side there? Well, okay. What do you think you would call that? What do you think you'd call that? In place of angle BAN, we're putting what it's actually equal to. What do you think you'd call that? What was what I didn't hear? Yes, that is substitution, because you're saying, oh, look, this angle measure is 2x minus 75. We're just going to plug that in. Okay, replacing or plugging in is substitution. Now, again, we got to have at least an S there, if not a T. Property of equality. I'm kind of getting out of line here a little bit. Usually I give you dividers to keep things lined up a little better. Okay, now the next step is saying 0 equals. 0 equals. So what would you have done to get that? Subtraction. What did you subtract? Subtracted x from both sides. Okay, and if you want to kind of show the steps here, if you want to sort of think through what's happening, that's fine. They're kind of doing that without showing the step, but it's perfectly fine if you want to kind of think through it by writing on the, the equation. Okay, and then 75 is equal to, we were solving for x, that should be x, right? How do you get that? Oh. Yeah, you added 75 on both sides, right? So that would be addition. Okay, so we'll come back and do this one tomorrow. On the homework, do the best you can. Sometimes this takes a little bit of practice to get better at it. Some of them you'll be able to do no problem, and others might be a little tricky, but just do the best you can with answering those.